All right. So hopefully this page felt pretty familiar and hopefully kind of easy. Cross my fingers. Is it something you've done before, right? You were doing this with Ms. Kotzen before I took over. So this one is just asking us to find the missing side. So if I am using this 72 angle, which is the one that I know, this side is the adjacent, and this side is the hypotenuse. And since I'm in a right triangle, I can just say that cosine of 72 is equal to adjacent over hypotenuse. And if I cross multiply, I get x times cosine 72 is equal to 6. If I divide both sides by cosine 72, I get that. And if I type that into my calculator, I get about 19.4. Everybody good there? Hopefully these are feeling easy. What would I use for this one? Which trig function would I want to use here? Still cosine, right? It's the exact same setup. And I'd write what over what? X over 6. So again, treat it like a fraction, cross multiply. And I type this into my calculator. I get 1.75. No, that's fine. So again, what Julia asked was, would it be okay if I said, oh, well, this angle is 17 degrees. Could I do like sine 17 is equal to x over 6? Sure, that's fine. No big deal. It's equivalent. Does not have to be cosine. There's nothing unique about that. Hello. How about this next one? Which function did I use here? If I'm using 24, I'm going to use tangent because this is the opposite and this is the adjacent. So again, cross multiply and I get x is 12 tan 24. And I get 5.34 for this. Still doing good? Okay. And this last one, which am I going to use here? Well, if I use the 49, this is op, and this is adjacent, so I would use tangent again. Cross multiply, that's going to give me x times tan 49 is equal to 14. If I divide both sides by tan 49, I get like 12.17. So these kind of problems should be freebies if I put something like this on the next law of sines, law of cosines test, or if I jumble some of these in here, you should be thankful whenever you see one and be like, yes, I can handle that. Everybody feel okay doing these kinds of guys? Yeah? Okay. Let's look at the law of sines and law of cosines page then. And again, can somebody help me out with which ones I asked you to work on? 1, 10, and 16. Okay. So these ones are newish, so we'll go kind of slow through them. So let's look at the situation that I have here. So the thing that I need to concern myself with is which one of those similarity theorems or similarity cases have I fallen into? Am I in side, 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 angle, side, angle, angle, side, angle, side, angle, or side, side, angle? If I look at this, I notice that I have two angles in a row and then a side. So this is angle, angle, side. Everybody agree with that? Okay. Could I have also said this is angle, side, angle? No, because the side isn't sandwiched in between the two angles, right? Does everybody feel okay with that? Okay. So this is an angle, angle, side situation. That implies I should use the law of sines. Everybody okay there? All right. So which side length of my triangle am I going to solve for first? Well, I'd have to find side B. Why do I need to find side B? Well, one, it's what I'm supposed to find, but if I ask you to find all the sides, still I'd have to start with B, because if I look at what I know, to use the law of sines, I need the angle and its opposite side. So we have to look at what we have versus what we need to know. Is everybody okay with that idea? Okay. So what I can say is that sine 92 over 15 is equal to sine 28 over B. Everybody okay there? I will then cross multiply, and I get B sine 92 is equal to 15 sine 28. If I divide both sides by sine 92, I have this. And then if I go to my calculator, 15 times sine 28 divided by sine 92 gives me about 7.05. And I guess our unit would be yards. Everybody okay there? What if I asked you also to find, what if I asked you, instead of just finding AC, what if we asked you to solve the triangle? What is that asking you to do then? Yeah, find all the missing pieces. So let's just kind of do that for practice's sake. What should I find next? Angle C or side C? Angle C, good. How would I find angle C? Yeah, 180 minus 28 minus 92, which gives me 60, I think. Yes. Okay. And then how would I find side C? Can I use the Pythagorean theorem if I don't have a right triangle? No. So I have two choices. I could do the law of sines, or I could do the law of cosines to get that other piece. Does it matter which one I choose to use? No. Since we used the law of sines before, let's do the law of cosines for this one, just for some variety's sake. Does it matter? No. So I'm just going to do that just so we have another time to see it, okay? So if I call this side side C, I know that C squared is equal to B squared plus A squared minus 2 times B times A times cosine of angle C, which is 60. So I'm going to type that into my calculator. And that gives me about 168.96. But what if I solve for here? C squared. I want just C, so I'm going to square root both sides of that. And I get basically 13.00. So that's how I could finish that guy off if I asked you to solve the entire triangle rather than just for that specific piece. Is everybody okay with that? So again, all it means is really we just have to repeat that previous step, right? Using either law of sines or cosines. Let's look at 10 here. So which situation are we in here? Good. We have a side, we have an angle, we have a side. This is side, angle, side. When I'm in side, angle, side, which formula do I want to use? I want to use law of cosines. So, even it tells you to find side AB next. That's the side you need to find. So the law of cosines is side squared equals side squared plus side squared minus 2 times those sides cosine of the opposite angle. Ian, do you need to go get a drink or something? Okay, you're just hacking up a lung. I was getting worried. Okay. Oh. Yeah, well, maybe it's time to go see the doctor. So there's my formula. Everybody okay with how I plug that in? I type this into my calculator, and I get that. But that's not really what I'm looking for. What am I looking for? Yeah, the square root of that, which comes to about 30.20. And I guess these are meters. Everybody okay there? What if we had also asked, in this case, instead of just doing this, but to solve the triangle? So what else do I need to find to solve the triangle? The angles A and angle B, right? So let's just choose to find angle B next. It doesn't really matter which one we pick to solve for first. How can I find angle A? Since it's not a right triangle, I have to use the law of sines or law of cosines, right? Doesn't matter which one that I use. In this case, I would be a little bit careful because technically speaking, if I do the law of sines, I'm in an SSA situation, which is the one where we have to be really careful at. We haven't talked in detail about why we need to be really careful. So I'm going to use the law of cosines because I think in general that's safer because you can't run into a two-answer situation with that. So if I do that, I have 19 squared equals 27 squared plus 19 squared minus 2 times 27. Why did I write 9? Oh, yeah. Why did I write 19 here? That's not what goes there. What goes there? The 30.20. Well, it asks you, I guess, to round to the 10th. So your answer would be a little bit off. I guess I did too much rounding, or not enough rounding. Everybody okay here? So I need to start by getting the cosine A by itself. So I'm going to subtract the 27 squared and the 30.2 squared from both sides. And then divide by the coefficient, which is the negative 2 times 27 times 30.2. And that'll get me the cosine A part all by itself. So take a moment and look at what I've done there. This is a little bit, it's a place where it's easy to make a mistake. A lot of students will forget that that's a coefficient in front of the cosine and like try to add or subtract it. Got to make sure you're doing the division. So at this point I could type that all into my calculator and get a decimal, or I could just do the inverse cosine to both sides and then type it all into my calculator that time, and that's what I'm going to do. Does it matter, though, which one that you do? Not really. Although when you type this into your calculator, what do you have to be really careful about? Yeah, there's a bunch of parentheses that need to be in there, right? I need a parenthesis around my entire numerator. And then I need a parenthesis around my entire denominator. And then I need a parenthesis closing my cosine inverse. Everybody happy there? Now, how would I get angle C then? Oh, I already have angle C. I would just write down the answer for angle C. How do I get angle B then? Can I do the same thing? I could do the same thing, but much easier is to just subtract from 180. So I can do 180 minus 80 minus 38.29. And that gives me about 61.71. And I guess I keep rounding to not far enough, but whatever. Everybody's okay there. There we go. And then our last one here was 16. Which situation was this in? This is the easiest one. Yeah. So which one should I use for side, side, side? Law of cosines. Everybody happy? Yep, me too. Okay. So I should start by picking an angle to solve for. Does it matter which one? No. In general, the one that I'm going to pick to start with is the one that's opposite the hypotenuse. How did I know that 28.7 was the hypotenuse? It's the biggest one. Oh, okay. And the only reason I do that is that you tend to get less negative signs running around. So if you are a finding the decimal in between steps type person, that sometimes can be helpful for you. So just like before, I'm now going to get the cosine B by itself. To do that, I have to subtract the 17.7 squared and the 25.6 squared from both sides. And then I need to divide by the negative 2 times 17.7 times 25.6. And now the cosine B is by itself. And what should I do then? The cosine inverse of the whole thing. So again, when you're typing this kind of thing into your calculator, what do you have to be very careful of? Parentheses. The entire numerator needs to be a parenthesis. And then the entire denominator needs to be a separate parenthesis. So when I type that in, I get 80.8. Now let's pick an angle to solve for. Which one do you want to solve for next? I don't know. I'm going to pick A. To solve for A, instead of using the law of cosines, I can now use the law of sines. So let's do that for a change of pace. I know that sine of 80.8 over 28.7 is equal to the sine of A over the side opposite A. So now I'm going to cross multiply and divide, and then take the sine inverse of both sides. So when I cross multiply, I'll get 25.6 times sine 80.8. And then when I divide, I'll get it over the 28.7. And then when I do the sine inverse, it'll go around that whole thing, and that will give me A. I've compressed some steps there in the interest of not having that much space to work with. Is everybody okay with what I did there? When I do that, I get 61.7 degrees. And to find the last angle, angle C, what can I do? I can just subtract from 180. Please make sure you take advantage of that property, because boy, oh boy, that saves you a bunch of time, right? Everybody relatively okay with this homework? The sine inverse of that mumbo jumbo above it. All right. Now we've been dancing around this idea for a couple of times now, as we've mentioned this over and over and over again. Let's start talking about it today. Yes. So this is the ambiguous case. Why do we call it ambiguous case? Because you can get more than one answer in this situation. So, in order to kind of make sense of this explanation, we have to recall a fact from geometry. That leg plus leg must be greater than the hypotenuse. What happens if they're not? Yeah. And yeah, that's the case. I was just trying to think for a minute if it could be greater than or equal to, but it's not. It has to be strictly greater than. So the situations are so if you're given an obtuse angle, the angle in the side angle side is obtuse. There's just one solution. You can proceed normally. Nothing weird can happen. Yeah, that says proceed normally. So nothing weird can happen. Everything is fine. It'll work just like your problems that we've seen to this point. if you have an acute angle, then we have to look at the side lengths. And there's two situations. Let's just draw our little picture here. Actually, let's do it this way. So I'm going to call this angle A. So if side A is greater than or equal to side B or C, depending on which one you're given, is there a duck in here? It's fantastic. Then we have one solution, and you can proceed normally. If A is less than B or C, depending on which one you're given, we get two solutions. Caution. So, for the test, I would expect you to be able to memorize when you're going to get more than one solution in this case. Okay? So I would give you the formulas for like the law of sines or law of cosines or whatever. Don't expect you to memorize that. I do expect you to memorize when I have to worry about finding that second set of answers. Okay? So just a couple of conditions. It's not really formulas, but I would expect that you have that memorized. So let's do a couple of examples here. Well, the way time is going, really one. So let's do this one, where we actually get to see the two solutions pop up. So note that the angle we know is acute, and the side opposite it is smaller than the other side that's given. So that tells me we're going to get two triangles. We have double the work. Oh, man. Okay, So if I'm going to do this, I'm going to use the law of sines. So I'm going to get sine of A over side A equals sine of B over side B. When I cross multiply and divide, I get that sine B is equal to 7 sine 30 divided by 6. And when I do sine inverse of both sides, I have that. Everybody okay to this point? Okay. So, when I type this into my calculator, I get 35.7. This is the point where the second solution is going to come in. You could also have this angle here . So the second triangle is what I'm doing over on this part. So that's going to give me 180 minus 35.7. Oops. So this is the first triangle over here. So I'm just going to go down and do this way. Sound good? And we'll just kind of work on them both at the same time. Now, angle C is easy to get now. We have two of the angles. Bless you. So that gives me 114.3 degrees. And here, C is 180 minus 30 minus 144.3. So I have 5.7 degrees. So far, so good. C is 114, B is 144. So they're different values. That's okay. Okay. What I do need to do now is I need to find that third side length. I can find that third side length either using the law of sines or law of cosines now. So I'll use the law of sines in this case, just for, I don't know, because I wanted to. I'm sorry, what? Here, this is A, this is B, right? This is A, this is B. No? Right, we were given in the problem, angle A was 30 degrees. That applies to both, stop talking please. That applies to both triangles. Right? We found B was either 35.7 or 144.3. If B is 35.7, angle C has to be 180 minus 30 minus 35.7. Yes, that's essentially it. So again, when you remember that law of sine, or that sine is positive in quadrant 1 and quadrant 2, so in this case, you can get a value for sine in both quadrant 1 and quadrant 2. So that's what's going on. So when I solve this one, I get 6 sine 114.3 over sine 30. Which comes out to be 1094. And then I'll leave you to solve the other one doing the exact same thing.